On this episode of the podcast, I have with me Nana Somuah. He is the Director, Data and Analytics at Cityblock Health. We're going to be talking about how data science and data analytics, they're kind of working with each other, and there's a bit of delineation between the two, and how people can, upskill and kind of, focus on making sure they're staying current to kind of fit the advancements in both sides of the field. Nana, appreciate you being on the podcast.
Appreciate being here. Thank you.
Absolutely. So a little context, what does Cityblock do?
Yes. So again, I'm the Director for Data Analytics at Cityblock Health. And for those who don't know what Cityblock does, so Cityblock is a health tech company. It's spun out of Alphabet Sidewalk Labs about 3 years ago, and it's based in New York City. So we are in the business of value-based care, which is basically, contracting with health plan companies and taking on their most complex members. So we take risk on their members with the mandate of basically helping the members improve their health outcomes and doing it at a lower cost. So we feel like we have the skills, both technical and clinical, to be able to take care of their members much better than the health plans do. So that is the business of Cityblock.
Absolutely. Awesome. And I know we're going to be talking a bit about, your area of expertise here, looking at analytics and data science and the skills required. I think how this started was we were talking about how the analyst role is getting to be just more technical. There's more pressure on getting into Python, being able to touch, some components of, modeling on the data science side. Obviously not full data scientist type of role, but it's kind of blending. And depending on the organization you're at, a data analyst could be doing some data science type work or data science title, even though they're not. I mean, there's nothing defined in the industry right now. It's kind of just a little bit murky for everyone. So I guess just get your point of view of how you delineate between, where data science and data analytics kind of work with each other, the skill sets and whatnot.
Yeah, I think that's a great question, and I think it's something that myself I've been, I had to answer a number of times because I think it's very important, especially as a leader in this ecosystem. So to answer the question, I feel like we need to go back, right? We need to go back and define data analytics, right? What is data analysis? In my view, I get data, which is the input. I come up with some output. Based on the output, I make a decision. And hopefully with the data, I'm making, better informed decisions. So if you think about that, data analysis is anything from taking the data, inspecting it, cleansing it, transforming it, modeling it for insights, and using that in decision making. As you can imagine, that is like a very, very broad discipline, and a lot of things can fit into that. So how do I break that down? In my view, data analysis, I have the business intelligence piece, which a lot of people are doing at work, which is, just doing aggregations, understanding trends, using it to answer business problems, and so on and so forth. That's one piece. The other piece, to me, is data mining, which is more statistical. That's where the statisticians come in. You think about predictive analytics. You think about, working on different data sets, structured, unstructured. So originally, and this is like a few years ago, we didn't have big data, right? The data that we had in the ecosystem wasn't as big. Folks were building models, predictive models, AI models on, limited data sets. Just recently, we've been able to get tons and tons of data. So if you think about big data is a recent phenomenon, if you think about it. In terms of the volume of data that we have now, the variety of data that we have, the velocity of data that we have. Sources coming from social media like Twitter, Facebook, we didn't have this. These are all recent technologies that we're kind of using. So we have social media data, we have websites, mobile, and there's even Internet of Things. So this is like so many petabytes of data. And so the traditional statisticians who were building these models on relatively small data sets now have to kind of upskill, if you think about it, right? Because you couldn't fit all the new data, all the big data into the traditional data warehouses, like rigid schema kind of stuff. Now you have data that is very unstructured, streaming data, and folks had to learn how to easily use that data for analysis. And that's where, to me, I think data science emerged from, right? Because now it's not just about structured data, it's unstructured. It's not just a few, terabytes, it's like getting like petabytes and so on and so forth. So the main difference between those, I think, is more to do with the quantity of data that we are working with and the tools that you have to start learning to be able to work with that data. So to me, like a traditional data analyst will be working in normal data warehouses, RDB, EMS, right, kind of data stuff. A data scientist will have skills to be working in Apache Hadoop, Spark, NoSQL databases, data lakes, and so on and so forth. And even just looking at the tools people use, just apart from the skills, Python is becoming very popular. In the late 2010s, a statistician would be using stuff like SAS. Now you don't even need to know. If you have SAS on your resume, you probably won't get a job, right? As a data scientist, it's now Python. So you can see there's a lot of changes going on. And to me, I think the main differences are if you're a traditional analyst with the way data is increasing, even in healthcare, for example, late 2010s, medical knowledge would double like in every 3.5 years. 3.5 years to double medical knowledge. In 2020, which is like 10 years, it's now 73 days to double the amount of medical knowledge available. So that should tell you how much data we are getting now. And to be able to cope and become relevant, you definitely need to get upskilled into these new tools or big data tools specifically to be able to do an effective work of analyzing data. So I know this is a lot of information, but in general, I think this is where the industry is heading to.
Absolutely. And I guess the challenge, like when you're looking at the analytics side of the house, it seems like there's a constant need to push into not only people delivering the key findings and the presentations, but our traditional analyst type of activities and responsibilities, but pushing into more technical, like obviously SQL is a given, but now are you familiar with Python as a baseline? Like if you can write Python as an analyst, you're more appealing than if you could just read Python. And it seems like there's pressures to kind of cope with the volume of data and the other tools that are just changing around them to kind of upskill what an analyst is capable of doing.
Yeah, definitely. So I think you hit the nail right on this. But if you used to be an analyst, you probably didn't have to know too much. You could be an analyst just without computer science training. But now it's becoming very relevant to kind of have that kind of training because you're working with very, very technical stuff like NoSQL, like Hadoop, very distributed computing systems. So understanding computer science, getting those skill sets, it becomes a requirement to be able to even do your job. If you cannot access or manipulate the big data, you can't do an analysis on top. So, initially, again, as traditional analysts, we didn't have to have that complicated or sophisticated technical skills, or you could just pick up stuff. You could actually even pick data from Excel sheets and do analysis on top. But now you really need the technical skills to be able to access the data because it's huge, it's streaming, it's unstructured, and that involves deep technical knowledge, big data skills, and that's where we are headed to with the data that we have.
Do you see your team, I guess, in terms of when you're hiring for your team and just previous experiences of having to account for these different skill sets you need? Obviously, you have data engineering, data scientists, and analysts. A lot of times you see people look for the overlaps. Like, I want an analyst that can potentially do a little bit of ETL manipulation, or I want data scientist that can do a little bit of data engineering. And you look at all these overlaps and you're like, maybe you could find those people to overlap. I mean, is that a challenge? Is that just because, it's easier to have one person do a little bit outside of the area? I mean, what do you see?
Yeah, I think that's an important question. And, in a startup like Cityblock is very, very important, right? Because the question is, in my mind, what is the maturity of the company or the organization? If you are in an organization that is big, like very, very big company, most likely you would have a more centralized, let's say data management function, a more centralized, let's say traditional data analytics, and a more centralized data science, right? It's always dependent on the kind of organization and do we have the infrastructure in place? If I'm hiring for a startup, I would prefer someone who has good overlap of skills, right? Because it's a startup. Most of the time, you don't have the infrastructure yet. So you need someone who can do some data engineering, who can do some data management, who can do some data and traditional stuff and data science. But if it's a big company and you already have the infrastructure and everything in place, you probably have a data lake, right? Because you need a data lake to be able to house both unstructured and structured data. Then you probably need someone with a little bit deeper, if it's data science, a little bit deeper data science skills, right? It's not just any data scientist. Maybe I want somebody who knows Bayesian techniques and stuff like that, and it could get very detailed. So, it's always dependent on the organization and maturity and the infrastructure in-house to kind of figure out, who we need on board. And again, if you're a small company, you're growing up, you're now building infrastructure, and you have, the components in place, and you have analysts who are probably not data, who can do those work, then you have to invest in professional development, right? For example, bootcamp is a good way to do that. There's online, data science courses and stuff. And you definitely need to get the budget in place to help upskill your employees so they can adapt and become relevant in this new ecosystem. So, those are some important things to look out for when you're hiring and when you're trying to upskill your talent.
Yeah, absolutely. And I guess when you're looking at people who are, let's say, analysts, and I talked to a lot of data analysts that seemingly all want to become data scientists, right? I think that they view that as the next level up for them, is to move out of doing the analytics and becoming part of the data science team. How does someone undertake that? I mean, it seems like a pretty big leap, but I mean, obviously it's doable. How would you recommend somebody go about starting that process?
Yeah, I think that's a good question. And I'm sure every manager kind of faces this at some point in their career. So I think that's very, very important. You know, I personally do not think it just comes granted. You need to put in some work, right? If I'm an analyst and I've always been working, and analysts could be very different in different organizations. An analyst could be somebody who probably is even using Excel to be doing analysis, a sub-analysts who are using, normal traditional relational database, building just SQL stuff, doing trending and aggregation and descriptive analytics in general. So the question is, where are you in your skill set, right? Depending on where your skill set is, to me, I think the main things you need to figure out is one, do you have the statistical training to be able to build models, do predictive modeling and all that kind of stuff. Getting those skill sets if you don't have those skill sets, because you could be an analyst and not have statistical kind of training or be able to build models. So you should be able to do that. That's one thing. Then you definitely need to learn the big data skills, which is new, which is, Hadoop, which is, NoSQL and all that stuff, and use the new tools, which is, Python, for example. So from the way I would approach this, or the advice I'll give folks who are analysts who want to become data scientists, is to make sure you enroll yourself, you learn the statistics, you kind of learn the computer science, the math, work on real world data. There are boot camps, there's Kaggle competitions, play around with some of the data, use the new tools, and learn the big data skills. And with that, I think, it's a good starting point. And obviously with experience, you become better and you can answer the hardest questions and be able to become a better data scientist. It takes time and effort. So, I think we should put in the work to be able to become a data scientist.
Absolutely. I was going to just ask you a question that you mentioned 73 days to double medical knowledge. Who's responsible? Like, I guess, I mean, maybe it's you, but how do you guys, obviously, I mean, Cityblock's maybe not seeing 73 days to double, but just with the amount of volume of data that's increasing in the medical space, who's watching like the analytics that are needed to cope with the additional data, to build additional models, to provide meaning out of it? Is that all fall under you? Do you have a specific product manager that's devoted to data analytics?
Yeah, so that's a good question. Things change every day. I'm in healthcare, so healthcare regulations change every day. For example, the standard of care 2 years ago will be different. It becomes outdated because we have new knowledge. So standard of care changes. So again, this underscores the importance of business domain expertise. As data people, we can only do as much as we can based on what we see in the data, but we need a very good collaboration with the business stakeholders. So in our case, it's mostly the clinicians, care team members who kind of live in care delivery and understand the science, right? The doctors, and they know that things are changing and they kind of draw us to, hey, this has changed, this new regulation is in-house. We need to modify our logic, So it's all about collaborating with the business stakeholders who deal with this day in and day out and making sure you are tapping into the most up-to-date and most relevant information to come up with your analysis. So it is a collaboration.
Awesome, man. I'm cognizant of our time. I was going to dive deeper into just the volume of data. Maybe we'll have you come back on the podcast to kind of pick up on a different topic because I think that'd be really interesting. But thanks for coming on the show and talking about, kind of this delineation of data science and analysts and the evolving skills needed to be, relevant in analytics. If someone wants to touch base with you because they have some questions on anything you talked about, what's a good way of doing that?
Yeah, so LinkedIn is always my number one spot. So you can definitely shoot me an email on LinkedIn and I'll definitely get back to you.
Okay, awesome. We'll include that in the show notes. Nana, thanks for being on the podcast. It's been great having you on. That's it for today's episode. We'll be back again, hopefully with different guests, different set of topics. And two things I always ask for. One is, leave a review on the podcast. I mean, the subscriptions are kind of going up. I'd like to see some feedback, even if it's directly to me on LinkedIn. I'm just kind of curious to see what else we can do to improve the podcast and kind of keep the upward trajectory, and also topic ideas. And, finding these different ideas are great to have people talk on. And until next time, thank you guys. Bye.